So there's a few other relational laws. So pressure is directly proportional to moles, and volume is directly proportional to moles of gas. The second one's called Avogadro's law. Most of these can be covered under a combined gas law that we talked about last time, and also pressure directly proportional to temperature, which is Gay-Lussac's law. And again, all these could be covered under the combined gas law. And so the ones that we did cover last time were Charles' law and Boyle's law. And if we take Charles' law and combine it with Boyle's law, and then add to it Avogadro's law that volume is directly proportional to moles, all these proportionalities can simultaneously be put together as volume is directly proportional to moles and directly proportional to temperature and inversely proportional to pressure. So like we did before with Charles' law and Boyle's law, we can take this relationship right here, which is a proportionality, and we can turn it into an equality by multiplying by a constant. And in this case, the constant is given capital R. This is called the gas constant. And so basically I multiply by R, and then I rearrange this, I get V is equal to nRT over P, where R is this gas constant. And then it gets related, they rearrange it to what some of you may have heard before if you've taken high school chemistry, or maybe you read the chapter, I'm not sure, to PV equals nRT. And to me, that is the quintessential gas law. And I never forget it because to me, it kind of looks like pervert, right? So this one's very different from the combined gas law. For one thing, there's no change. So remember with the combined gas law, the temperature increased or the pressure decreased or the volume went down, right? There's no change. But what the ideal gas law says is that if I know 3 properties, I can find the 4th property. And the other thing is I must use units of R. R has a really funny set of units. It's liters times atmospheres over moles times Kelvin. You have to convert the other 3 properties into liters, atmospheres, moles, and Kelvin, and then you can solve for the one that's missing. So PV equals nRT is really 4 equations. Written that way, it doesn't solve for anything. But I can write it as V is equal to nRT over P if I want to find volume, right? I can write it as P is equal to nRT over V if I want to find pressure, right? I can write it as N is equal to PV over RT if I want to find moles of a gas. And I can write it as T is equal to PV over NR if I want to find the temperature of the gas. But there's 4 properties. There's pressure, volume, temperature, and moles. And so I'm given 3, I can find the 4th one, whichever one it is. If I want to find volume, I'm going to need moles and temperature and pressure. If I want to find pressure, I'm going to need moles, volume, and temperature. If I'm going to find the temperature, I'm going to need the pressure, volume, and the moles. If I'm going to find the moles, I'm going to need the pressure, volume, and the temperature.